Rounding us off today, we have a dynamic duo from Baker Hughes Turbo Machinery and Process Solutions in Italy. Andrea Intieri is platform lead for pipelines alongside his duties on the Pipeline Technology Conference Advisory Committee and as Italy's chair for Multicultural Employee Resource Group, promoting inclusiveness across different cultures within Baker Hughes. Joining Andrea is his colleague Alessandro Carnevali, DTI Manager for Service. His current duties are mainly focused on centrifugal compressor upgrades for all applications, downstream, midstream, and upstream. He joined the company as a centrifugal compressor design engineer, covering rotor dynamic and thermodynamic design and testing upstream, pipeline, and integrally geared applications. Welcome, gentlemen, and please talk us through pipelines decarbonization, innovative technologies for new and existing compressor stations.
Thanks a lot, Danny, and good afternoon, good morning, everyone, to the people connected. Thank you to the Virtual Pipeline Summit organizer for inviting Baker Hughes to join such an important event. And today, really, we are going to talk about pipeline decarbonization, in particular about compression station and how technologies can help at 360 degrees decarbonize existing compression station as well as new installation. Alessandro and I are part of Turbo Machinery and Process Solution, or TPS, which is a product company within Baker Hughes. The portfolio of TPS clearly is very large, but in particular there are some specific product line that in particular allow to reduce emission and in particular integrate very well with renewables. Starting from drivers, clearly the gas turbine, in particular the aeroderivative and the innovative NovaLT family of gas turbine with a very high efficiency level that can help the decarbonization, as well as the expanded portfolio coupled with the waste heat and pressure recovery system. One product I will talk about later in my pitch will be the integrated compressor line, or ICL, which is another innovation that allow, let's say, zero emission into the atmosphere. Baker Hughes has also an important portfolio of carbon capture, utilization and storage, and energy storage solution. Last but not least, Baker Hughes has also capabilities for deflaring plants, basically bringing to the next level the needs for decarbonizing and transforming the core in the oil and gas industry. In this chart, you can see an overview of the gas transition system, the gas transmission system. The dotted black line is basically the high pressure network that is, as we know, connecting the upstream production to the typical end user, residential, industrial, and power generation. There are multiple points among these two extremes. There are multiple technologies that today can be implemented in order to decarbonize, on one side, the operation of the gas transmission. So the key role of the pipeline operator, and on the other side, to decarbonize typically hard to abate sectors such as heating and transportation. Many of these technologies have been mentioned today already. They include clearly new fuels like any color of hydrogen, and in particular the blue and the green, as well as biogas. Gas and power sector coupling has also a very high potential, according to our opinion, because it allows basically to leverage the molecules and the long-term at low-cost transmission of energy when compared with the high-voltage grid. Fugitive emission clearly play a role in this mix, and we'll talk about this also later in the pitch. Last but not least, clearly replacing old-fashioned gas turbine with the new high-efficiency model, as well as implementing waste heat and pressure recovery system, can really allow a full decarbonization of the pipeline system. So let's start with hydrogen. Talking about hydrogen, it is important to touch about the wide experience that the industry, in particular Baker Hughes, has gained over the years. We have a fleet fleet of roughly 70 units that has been running with rich H2% up to actually 100%. This portfolio of product includes different technologies like the typical heavy duty, the aeroderivative gas turbine, as well as the light industrial, in particular the NovaLT family. Two are the cornerstone that are behind, let's say, this experience. One is a full-scale demonstration plant that has been developed in Italy years ago with a GA10. This is a demonstrative project with an Italian utility that has been very successful and allowed to gain experience in burning hydrogen. On the other side, the NovaLT technology has also been tested with the dedicated combustion test up to 100% hydrogen and demonstrated the capability to start up with 100% hydrogen. The same project has been also developed together with an important pipeline operator, the biggest in Europe, Snam, which basically have been testing a 10% hydrogen blend, the NovaLT12 technology, which will be installed in the Italian gas grid in northern Italy later this year. With this, I would like now to leave the stage to Alessandro.
Thank you, Andrea, and good evening, everybody. The compression of hydrogen is a market that is largely used in the oil and gas industry, in particular for downstream plants. And we are used to serve this market basically from the beginning with our centrifugal and reciprocating compressors. Here I collect basically the list of our milestones related to the compression of hydrogen. So you can see that our experience with the first reciprocating compressor started in 1922 with the first ammonia syngas train, where the hydrogen content was higher than 75%. Then we installed the first reciprocating and centrifugal compressor 60 years ago, which was handling basically 100% of hydrogen. And then we continued during the years up to a few months ago when we sold the last reciprocating compressor that will be installed in a green hydrogen plant. It basically will take the hydrogen from electrolyzer fed by renewables, and it will push the gas to the grid for transportation. So during this year, we got a lot of new plants. We installed something like 2,400 units working with hydrogen, with more than 75% of hydrogen, and something like 960 units working with basically pure hydrogen. On top of this, we have also some strategic agreement with some main players. The last one announced is with the Air Product for the construction of a large-scale new plant for hydrogen production. If we go to this slide here, I try to summarize a sort of, let's say, some takeaways to understand what are the impacts that blending hydrogen on existing equipment designed for natural gas may have. The hydrogen presence basically affects the materials and the thermodynamic performances of the centrifugal compressors. Material because of the so-called hydrogen embrittlement phenomenon, which is a matter of partial pressure, basically. So if we try to draw a sort of line to understand what may happen in a typical pipeline at 70 bar, we can see that considering the compressor designed for natural gas up to 5% of hydrogen, we do not expect any issue on the material. At 5%, we need to check something around the flange-to-flange compressor, so mainly auxiliaries. And at 10%, we need to check the material of the rotor of the compressor. From thermodynamic standpoint, basically adding hydrogen means reducing the weight of the gas. So we need to make the same pressure ratio, higher power, and to run faster. Of course, in case we want to transport the same energy as before, so we need to increase also the flow, and it will increase much more the speed and the power. By the way, due to the complexity of the case, this is something that we can do only with the detailed study to see case by case what happens. In case existing compressor is not able to manage the new hydrogen blend with the as is, what we can do is to approach with some upgrades. The first one could be, for instance, to change the bundle, the internal part of the compressor, by introducing high head impellers, or we can increase the speed a bit by adding basically a gearbox between the gas turbine or the driver and the compressor. But if it is not enough, or if we need more impellers or more compressor body, what we propose is what we call the HPRC compressor. The HPRC compressor means a high pressure ratio compressor. This is a centrifugal compressor that we introduced a few years ago. It was born for upstream offshore pipe air injection plant. And thanks to his new design, we are able to run faster compared to the standard compressor. The main difference with the standard compressor basically are two. One is that we basically the stages are connected by HIRT, tightened by tie rod, and they are not impellers shrink fitted on the shaft, so there is not the risk of loss of interferences due to the high speed, and the introduction of open impellers, which reduce the stress on the impellers. In this way, basically, we can increase the speed of roughly 50% compared to a standard compressor. And since the head is proportional to the square of the speed, it means that we can do the same service with half number of impellers, so half number of compressor body. Here I try to show you a case study, just to give you an evidence of the benefit you may get. Consider a typical value of flow and pressures from the North America. So if we want to face this condition with a standard pipeline compressor with the peripheral speed of the impellers of 250 meters per second, we may need 5 compressor bodies. If we use the high head impellers, we can consider just 3 compressor bodies. But by using an HPRC compressor, basically we can do the same service by using 2 or even 1 compressor body, with a huge benefit in terms of layout, of course, in terms of capex and opex, and not only because of flange to flange, but also for all what is around the compressor, so auxiliaries and whatever.
Thank you very much, Alessandro. Of course, decarbonization does not mean only hydrogen. Another very important trend, specifically in Europe, but also in other regions of the world, is the trend towards electrification. And when talking about electrification, as you can see in the top part of this slide, it is important to introduce a very innovative product, the ICL, or integrated compressor line. Basically, it's a motor compressor, but it is composed by a single casing, including and hosting the compressor and the high-speed motor directly coupled. It has no lube oil system and no dry gas seal. That means that it is a compact machine. It is safer, and it is integrated. So there are no leakage, no fugitive emission in the atmosphere provided by the ICL. It's a machine that is already referenced in pipeline and storage application with multiple reference, approximately 50 units running. And today this product has been also released for being tolerant to hydrogen blend. So we see a lot of future development based on the electrification trend. On the other side, we are now talking about the so-called hybridization of compression station. That means using different fuels to run the compressor, and so to maintain the flow of the gas inside the high pressure network. To do so, we propose what we call the typical hybrid gas turbine that you can see at the bottom of this page. Basically, you take a typical turbo compressor and you equip it with 1 or 2 clutch and with an electric motor. You can run this system just like an hybrid car with the gas turbine, for example, going at base load, and that energy can be used to compress the gas, and at the same time, for example, you can use the electric motor as a generator to generate power and, for example, to balance the renewable and the intermittence of the renewable sources within the power grid. At the same time, you can take the power from the power grid and run the compressor using only the electric motor and disconnect the gas turbine. You will have no emission, and of course gas turbine life extension. So we believe this is a very important product for the future, enable gas and power sector coupling, and most of all, it also allows, thanks to an energy optimizer, to make some price arbitrage between gas and power, leveraging the most convenient fuel depending the time of the day and the season, and running this system even in parallel with the gas turbine and the electric motor, running the compressor at the same time. To complete my presentation, I would like to briefly introduce the methane leakage reduction. The previous presentation have already touched on how important it is to reduce fugitive emission, and in particular, compression stations are one of the biggest sources of fugitive emission. This is the reason why we are releasing this product, which allow, once installed, basically to bring down to near zero the emission from the compression station. It is basically a very compact skid equipped with a reciprocating compressor on top. The reciprocating compressor will take the primary event, so the gas leaking from the dry gas seal of the centrifugal compressor installed in the compression station, as well as the compressor loop when you have yearly 1 or 2 stop in your for normal maintenance operation. The way it works is that this system will recompress the gas and send into the suction header of the station. So basically you have 2 advantages. You are saving money because you are not burning the natural gas, you are not leaking the natural gas, as well as also you can leverage, for example, a carbon price. And this is overall leading to a fast return on the investment. This is a system and a solution that is pretty simple, is already under delivery for 3 European pipeliners. And for a typical pipeline compression station with a PCL 600, that is a typical size that is installed in pipelines worldwide, we have estimated that this system in a year can help save up to 2,500 tons of CO2 equivalent, which is corresponding to a significant amount, that is approximately 10 million kilometers of a passenger vehicle. With this, I would like to thank you once again, and of course, we are available for any any question you might have. Thank you.
Thank you very much, gentlemen. Great presentation. It's great to see you're making rapid progress in these fields. And also great to see, the other benefits aside from decarbonization that we see by this improved technology, like lower capex, lower opex, easier maintenance, and hybrid flexibility as well. Okay, we're actually running very short on time, so thank you so much again for the presentation. And
thanks a lot, Danny.
Thank you, guys. I'm going to hand back to you, Dennis, now to take us home.